Okay, just testing. Right. So, just we've just done this, but this has been a great. This is a cross-functional talk from a cross-functional piece of work, and I always love it when that happens because it reminds me of startups, which is where everyone works really well together. So we'll get more into this now. So the origin story of this talk is 6 months ago. I was bringing our new CEO up to speed on the extreme sadness of trying to get benchmarks in every country and every category. And it's that new CEO, why can't we sell there? Why did we lose this thing? It's like, oh, yeah, because we don't have Peruvian tea drinkers. And customers, we go through the whole process that everyone goes through when they take over this revenue drive. Can we not just build them when the customer says they're going to spend? We go and build the norms. They launch one cell. So illustration of the sadness is between all the countries and categories, we have depth for 2% of those combinations. We have some data for 7%, and it would cost us $49 million to close all the holes. Obviously, that's a bit of a provocation of a statement. Maybe some categories don't exist in some markets, but it's directionally correct in its sadness. So very much in the spirit of the theme today, I was thinking, there's got to be a way of getting more value for less money. And also in the spirit of the previous talk, so our research team, I deeply respect them. I also consider myself a little bit of an imposter, although I've been here for 15 years now, so something's stuck. Deeply respect the research team, and I didn't want to just tap them on the shoulder and say, hey, I've just had a brain fart. Like, is there any way we could just not do all the things we've been doing for a long time and get into that whole thing? They're very busy and doing very, very important work. So I thought, let me first have a little, not quite vibe coding, but just a session on the couch with my robot friends to see whether we could model the effects of country and the effects of category and the combinations in a way that would allow us to fill the gaps of some of our sort of third-tier markets where we wouldn't really want to invest. I didn't go the Studio Ghibli route. I also think the AI is trying to flatter me. I don't think profiles as good, but yeah. So the journey with I started with Claude and ChatGPT, and I spent quite a bit of time going into the prompts of what the problem was, what the data looks like, and it came up with some interesting ideas, which I'm sure some people here have already thought of, but it was interesting. So I spent the afternoon running with them and thought, well, I'm not going to, this could be complete nonsense, so let's see if I can validate it. So it's pretty, I then entered a vibe coding state. I didn't use Python because one of the algorithms was actually more, I think it was more mature in R. I haven't used R before. Traditionally, say 3 years ago, if I'd run into this problem, I would have gone, okay, great. I've got this algorithm. It does exactly what I want. It's in R. Now I'm going to try and spend the afternoon converting it to Python. I just skipped that step and immediately started producing validation in R. Of course, I don't really know what I'm doing, but I got some really interesting results that I thought, okay, it's worth tapping the shoulder on. Nobody should ever deploy CTO market research. I'm not coming for your jobs. I don't really know what I'm talking about, but I think the big advance here, at least from the framing of how this started and the role of AI, is it presented we could have a conversation a little bit further down the road than sort of just sort of the brain fart stage. I could say, okay, well, there's a little bit of structure here. Tassia, Jack, is there anything to this? And and I will hand over, as I did with this, to Tassia.
Thank you. Let me get this. Thank you. I do code in R because I graduated too many years ago, probably. So back then, if you were learning statistics, it's R that you are using, or SAS. Does anyone still use SAS? But yeah. So that's exactly what happened. Brendon came and said, "Wow, I did this thing, and it looks okay." Well, so the challenge was, can we imagine a scenario where we could create norms where we don't have any data based on predicting norms, basically. So where we have data, we stick to the number. Where we don't have data, let's try to predict it. Let's explore. So it was an exploratory work to start with. And we tested initially, can I pass? Oopsie. We tested initially 2 models. So the first model tested was a linear mixed effect model, and that's pretty much an extension of a regression for cases where you have a lot of correlations. So in this case, we had country data. So there's a lot of clustering and correlations within the data set, so a linear regression wouldn't be suitable, but we tested with linear effects model. The second model included, it's a similar one, but included a Bayesian effect, so included the prior information about the countries. And what we're going to do through this presentation is talk you through the results, the initial findings, and where we are going with predicted norms. So model 1, it's the idea that you could create a prediction based on estimating an effect for the country, an effect for the category, have an intercept, have an error, put them all together, and have a prediction in that way. We have, of course, it's market research, so we have lots of types of data. So we do have norms for average. We have norms for top boxes, top 2 boxes, bottom 1 boxes, bottom 2 boxes. We have metrics that are in a scale. We have metrics that are based on behavior data, for example, engaging with a video, clicking, putting emojis. So we have metrics that we call them behavior. So we have behavior, we have some scales, we have different types of metrics. And of course, we wanted a model that would work well for the majority of our metrics. We tested as well, we have a difference here. So sometimes we were trying to calculate norms where we have a lot of information on the category and we have a lot of information on the country. So we have seen and observed both of them. Sometimes we're trying to predict a category where we don't know much about the category, so it's a new category, but a country that we have seen, and sometimes it was the other way. So it was, so sometimes we were trying to predict things where we had data on the country, or we had data on the category, or we had data on both. So there was a bit of a difference, and that matters for the second model used. I put 2 examples of outputs just to show you how we were looking at the effects. Oh, this is not the example yet. So here are the R squares for model 1. Again, model 1 was very, very simple. Simple, linear, easy model. And the R squares are quite high, so for most of the metrics. So this is our advertising solution, all the KPIs there. The R squares are way above 90, so it goes from kind of 87 to 98, so very high R squares. In the interest of time, I didn't put the errors, I didn't put the measures of fitness, but the model fitted very well. The errors were relatively low, so we're quite impressed for such an easy, basic model to start with. Then I put 2 examples just to show you how we were looking at country effects and category effects separately. So this was an example for a distinctiveness, which is a metric that we have to say how different this is from other ads that you've seen. And you can see category effects for all the categories, how much they vary, country effects, how much they vary. We were looking at it to see if that made sense with what we know. So for example, at the bottom, we might not be able to see, but you have mobile service, broadband internet. You can also see the rank on the country, how different the scores were, and same for another metric. So the metric before, this is the 5-point scale. The next metric is watch full ads, so it's kind of the percentage of ad watched or yes, no, if you have not watched yet. And again, looking at the category effects and the country effects. And when we looked into detail in advertising and innovation, it was really, really important to us that, you know, the things we were seeing in the model made sense with what we know about the data. And it did. This is a chart showing how much more important the country effect is compared to the category effect. We all know that. We all know that there's bias and different markets score differently. But it's really interesting to see how different that was. So these are the predictions interval for situations where you have seen the country and you have not seen the country. So the point that you see here, right at the end, is situations where you have not seen the country. So you can see how far the predictions are, how big and how wide the prediction intervals is. And then here is when you have not seen the category, much closer. And here in the middle is situations where you have seen both the category and both the country. So they're much better scenario. So we applied that to a real-life application. We looked at two categories. I just brought these two as an example. So this is Canada, bottled water, Germany, non-alcoholic energy drinks, and we compared the estimates to the observed and did a bit of the difference divided by the standard deviation just to see how much that difference was compared to the variety that we see in the data. And again, you might not be able to see, but some of them are quite well predicted. Like you can see that it matched up to the first decimal quite nicely. So we were very impressed with, based on this model that was very basic, the predictions were kind of okay. So what we've learned was three things. There was a good fit in the model, despite being a model that's relatively simple, good fit. It was explaining a lot of the variance. Second point, it did make sense with what we know about the categories and what we know about the countries. And the third was that we have very decent predictions to build on. So this was a very initial model. Let's build on, let's improve in this model, and let's take it from there. And then Brooke looked at some cool stuff to improve the country effect.
Cheers, Tassia. I'll grab that. Cheers. Cool. So as Tassia just said, we attempted to see if we can leverage external country data into our modeling to boost predictions where we have low occurring countries or we've never seen a country before in our survey data. So if we have a lot of, we have a lot of data for a lot of survey data in the US and the UK. We have less survey data in Thailand and Vietnam. So our predictions, our random effect predictions, tend to be a lot worse in these low occurring countries and unseen countries. So this is why we look to external data sources to get around the sparse data problem. So how did we do that? This is the most, this is the most formula slides you're gonna see from here on. So we downloaded a bunch of external country data. So this is data about countries, religiosity, geography, economic indicators, demographics, this sort of thing. And one of the implicit assumptions in Model 1 that Tassia talked about is that these random effects between countries and between categories are independent of each other. So what that means from the model's perspective is that it cannot use, say, Vietnamese data to estimate the country effect for Vietnam, for Thailand, even though Thailand and Vietnam might actually be quite similar. So we wanted to leverage this similarity, and we thought we could use this external country data to do so. So what we did is with the current model, we just introduced this dependency directly. So rather than allowing these country effects to remain independent, we impose the dependency here. The details don't really matter too much, I don't think, and they're not particularly interesting unless you're a bit of a nerd. But we do that in this G matrix here. We derive a similarity matrix from the external country data, and then we add it into this covariance matrix here. And what that means is that rather than drawing these country effects from independent distributions, we group together a big, massive country effect vector, and we draw it from a global world distribution. So that's the first. That's the first way in which we use this external data. And what that means is we can have this strength borrowing effect. So when we're making Vietnamese predictions, we can borrow strength from Thailand. We can borrow strength from US data as well, which I have a lot of. But we'll borrow less from US data, right? Because the US is a lot less similar to Thailand than Vietnam is. The second way in which we did that is we tagged on some fixed effects country features. So you might remember from a few slides ago, the mixed linear model is actually quite a simple model. It's just the addition of a few terms. We just added on a few extra terms. What these terms represent are essentially these external data features, so religiosity, demographics, income, and it's just this country, it's just each country represented in these coordinates, basically. So it's a 3D representation of these countries in this vector space, which is defined by these features. So what's the value of that? Like, so if we've never seen a country before, and we're not able to estimate a country effect, say, then we have this as a bit of a backstop, these fixed effects country features. We can rely on these fixed effects if our country effect or category effects are small. And so we can draw correlations, the model can draw correlations between these features and our metrics of interest, so our distinctiveness, say. So these first two things happen at the very beginning. So this happens during model training or model definition. We define these things up front and we let the model estimate these parameters. This last bullet point here, estimating unseen country random effects, that happens during prediction. So it's just a bit of a trick, really, but it turns out to be pretty effective. If we've never seen a country, so we don't have, let's say, pick a random country, Indonesian data in our data set, then we can estimate that country random effect as a linear combination of the country random effects that we do have data for. So it's just a weighted mean, essentially, of all the other country random effects, where the weights are again determined by this similarity matrix, which is again derived from this external country data. So all of this is leveraging external country data in situations where we don't have a lot of data. Okay, cool. So that's the technical side. Does it work? The short answer is yes, it does. Particularly in low occurring and unseen countries. The model, so this blue line you're looking at here is model 1 performances. So all these countries here we have our low occurring countries in our data set, or unseen in some of them. And model 1 is the error here, the blue line, sorry, is the error in model 1, and this orange line is the error in model 2. So in almost all instances, with the exception of 2, model 2 outperforms model 1. The overall error reduction is about 50%, so it's half as much error in model 2. Are we going to put these predictions in front of customers in areas where in countries where we don't have a lot of data? Probably not. But I think what this does demonstrate, at least, is that this principle of using external data about countries and maybe categories is a useful principle, and we can use that to learn and inform future decisions and experiments in this work stream. So what's next? So the first thing is to iterate on this current model. It's a very simple model, despite some of the earlier slides. The underlying model is a mixed effects model, so it's linear, and it captures a lot of the variation that we see in our metrics. But maybe we can experiment with more complicated modeling. Hierarchical models is something that's come up a bit in our discussions. And maybe we can do something with category effects, right? I just talked about leveraging country similarity to boost predictions. Maybe we could do the same thing with category effects. Another thing we want to do is we want to test this with parent level categories. So everything we've shown so far is to do involves child level categories, but parent level categories tend to be more relevant for our clients. Also, we've been talking about the country effect and the category effect, and even in this second version of the model, country and category is still independent. So can we explore interaction terms, right? Do we know that specific categories test very differently in specific countries? I think we do. Can we encode that in our model? And lastly, we want to test this on more data, so more solutions. And then I think Jack's going to talk about how we might use this.
Cheers, Brooke. Yeah, I mean, I think the first thing to say is norms mean something for customers. So really, when we think about how we might deploy this, there's a lot of expectations. You know, a norm is something that is traditionally something organic, based on prior testing, based on relevant comparison points. I think it's fair to say that were we to go to market with this aggressively, a lot of behaviour change would be required, and we'd probably have quite a negative reaction in some cases. So we need to be careful in terms of how we position this, how we start using it. I think the other thing to say as well is, of course, a model like this is to some extent only as good as the data that we put into it. At Zappi, historically, we have done a lot of norms building. Typically, that's been to achieve a database of a given size, to produce a benchmark that we allow customers to compare their data to. I think that the big implication of this might be that we change how we do some of that spend. When we look at building norms in future, we are probably going to focus more on, less on having a lot of cells within a given combination and more on breadth instead of concentrating that data, which is quite exciting because it allows us to look at enabling, globally much bigger footprints. But in terms of I guess the principles we're looking at from the product perspective of, taking this to market really is, I think there'll be more acceptance for this kind of approach in more obscure markets where we don't typically do a lot of research, typically high CPI, small databases. We only really want to deploy this as well in markets where we know about cultural response biases from previous research, particularly online cultural response biases, of course, and of course where we know about the category as well. So at Zappi, we know a lot about salty snacks, we know a lot about carbonated soft drinks. Those kind of areas, getting those into more obscure markets would be a natural starting point for something like this. And then, very importantly, we are not going to do predictions that a customer would use based on, unseen information at this point in time. So yeah, I mean, that really covers it. But I think the key point here is, the other side of this coin is, at the moment, our norms are purely organic at Zappi, right? We maybe do a little bit of gardening, take some stuff in, take some stuff out, but they are, purely based on mean scores, top box averages, whatever it may be. In my mind, at least, where this really takes us is in a direction where we stop having such blunt mathematical calculations to derive a norm or a benchmark, a simple average, and we use a lot more information. So, our salty snacks norm in the United States, I could easily see that in the not too distant future be, a norm which is based on this model, what this returns in the United States for salty snacks. But why would we not want to use all that additional salty snacks information we have from many other markets? It seems inefficient not to take some of that data in. Yeah, that's where I see us going with this.
Excellent. I mean, some excellent work has gone in there. It kind of took me back, I think probably about 15 years ago when we were talking about how difficult it was to build and maintain consumer panels in lots of countries. And I said quite flippantly, why don't we just build a very big one in China and just culturally weight all of the answers? And maybe that wasn't such a ridiculous idea 15 years later. I will ask the floor for questions.
Thank you for the presentation. You mentioned that there were some negative responses or reactions when bringing the idea or concept to clients. What were those negative reactions, and what proportion of those were actually well-founded versus debatable?
I think the answer to that really at this point is we're anticipating that. We've not really spoken to customers in depth about this yet. We've done the discovery in terms of the technical side. We now need to do the discovery with customers. Well, I think it's about what people may be used to. Non-synthetic, you could call it synthetic, you could call it derived. People are used to market research being directly observed data from populations. They're used to benchmarks generally being non-synthetic in source. So it's bringing that additional element into the mix.
Given that the most widely used technique in market research is probably the t-test. Do you think clients are ready for a more sophisticated norm model?
No. I think we need, a serious answer is we need white papers, evidence, we need to convince them, right?
Thanks. Really interesting ideas, and it reminded me a lot of norm work that when I worked for a big agency a few years ago. Norms was very key then. Just trying to understand with your, this is more broader about the way you handle norms, but perhaps with the unseen category and unseen country stuff is more important. Do you use time as a variable at all, as in when the data is captured, when the norm, the data that's going into your model, and the data that's decaying from the model? Do you have like a decay curve for that?
I'm going to have to hand over to these guys to talk about the model.
This exploratory work was using our whole database, which is based on the organic norm. So if we are to implement and to test it further, it will probably have a time cut on what goes into the predictions. But at the moment, it was just exploratory, and it was based on our entire database. So there isn't a time frame.
Apologies for my naivety, but could you take a country where you got lots of data and pretend you didn't have a lot of data, and then see how valuable your methodology is?
Yes, I removed the entire US from our database and started putting it back one by one just to see what it does. So yeah, it's an interesting exercise to do. Of course, the more, the better. But yeah, it's certainly one of the things we looked at. And it's one of the ways that we can estimate the errors. For example, you randomly select some stuff to keep it out of the database, put it back in, and see where the errors are in the predictions. So yeah, it's good fun. Yeah.
I've got a question. One of the things that struck me is like the assumption that there was independence per country of the geographic effects of the religiosity. Have you tried to segment the countries? To try to see like which one was similar and build different coefficients for each of them. And in the end, you can always overfit, etc. Have you tried machine learning? Because it's complex and it might work better than simple, multilinear correlation.
Yes. So that second model is, so we're not segmenting groups of countries, we're segmenting individual countries. So for every single country, we have a number which tells us how similar that country is to the rest of the world. So to every single country in the rest of the world. So we are essentially doing that. And so that is in that second model in that Bayesian implementation. Yeah, if that answers your question.
Thank you.
Okay, we're going to bring that session to end. Thank you all for an excellent presentation.